This is Mrs. Doris with Lesson 8-4 entitled Multiplying Special Cases. Our objective is that you will find the square of a binomial and that you will find the product of a sum and a difference. As we go through the lesson, this will make a little bit more sense to you. Alright, so the square of a binomial. The square of a binomial is the square of the first term plus twice the product of the two terms plus the square of the last term. All right, so applying this to the problems that we have, we're going to take the first term, a, and square it. We're going to take the product of the two terms, a times b, and take twice that, so 2ab. And then we're going to take the last term, b, and square it. All right. Let's apply the same thing to the next one. A squared is a squared. A times minus b would be a minus ab, and we want twice that, so it'd be minus 2ab. And then minus b squared would be a positive b squared. Negative b times negative b would be a positive b squared. All right, so now let's apply it to something that has some numbers in it. All right, so our first term, x, we're going to take x and square it. We've got x times 8 would be 8x, and we want to take twice that, so it'd be plus 16x. And then we want to take our last term, 8, and square it. And 8 times 8 would be 64. All right, and one more. We're going to take our first term and square it. We're going to take the product of x and negative 5, which would be negative 5x, and double it. So that would give us negative 10x. And then we're going to take the last term, negative 5, and square it. Negative 5 times negative 5 would be a positive 25. Now, this rule can be used. However, you should also note that you can simply use one of the methods from Lesson 3. For instance, and this kind of shows why it works. Let's take our x plus 8 squared. And I'm going to just write it out as two factors, x plus 8 times the quantity x plus 8. All right, so let's say we use FOIL on this. X times x would give x squared. My outer terms, 8 times x would be 8x. My inner terms, 8 times x is 8x. And then my last terms, 8 times 8 is 64. So notice that my two middle terms that are like terms that I can combine are both the same. So I've got two terms that are the same. And so 2 times 8x is 16x, or said another way, 8x plus 8x is 16x. And that's why this method works. So if you don't remember the little rule up above, and I admit that can be a little bit tedious at times, you can always write your factors out like we did right here and go ahead and use FOIL or one of the methods that you learned in Lesson 8.3. So our final answer would be, of course, x squared plus 16x plus 64. All right, so we're going to square these binomials. And once again, you may choose to use the rule. I'm going to demonstrate that here, but be aware that you can write the factor out twice and use FOIL or a method from Lesson 8.3 on it. Okay, we're going to take the first term and square it. All right, We're going to take the two terms and multiply them together, which would give negative 7n, and then double it. So it'd be minus 14n. And then we take the last term and square it. Negative 7 squared would be a positive 49. On our next problem, we're going to take the first term and square it. 2x times 2x would be 4x squared. All right, next I'm going to take the two terms, 2x times 9, and multiply them together, which would give me 18x. And then I want to take twice that. Once for my outer term, once for my inner term. So 18x plus 18x would be 36x. And then I want to take my last term, which is 9, and square it. 9 times 9 is 81. And that would be, those would be my answers. All right, problem 2, we're going to apply this to a geometry problem. We have a square pool is surrounded by a 4-foot walkway. What is the area of the walkway? Well, what we're going to do is we're going to take the area of the larger square, all right, which is x plus 8, and we're going to square that in order to get the area of the large square. And then we're going to subtract out the area of the smaller square, which is x by x, and that would simply be x times x is x squared, and subtract that out. All right, so let's use our special formula for a square, excuse me, a square of a binomial. So we take the first term, x, and square it. What we find here is our outer term and inner term are exactly the same. So x times 8 is 8x, and double that gives us 16x. And then our last term squared, 8 squared is 64. And then we want to subtract out the smaller square. All right, well, x squared minus x squared cancels each other out. So we are left with 16x plus 64, and that would be our answer. That would be the area of the walkway, which would be left. All right, now let's see if we can apply this and use some mental math to find the following squares. We're going to take 85 and square it. So what we're going to do is we're going to rename 85 as 80 plus 5 and square it. All right, so using our little rule, we would take 80 squared, which would be 6,400. We're going to take the product of the two. 80 times 5 is 400, and double it, which would be 800. And then we're going to take the last term, 5, and square it, which would give us 25. So when we add these up, we would have an answer of 7,225. All right, let's use the next one, 69 squared. And this time, we're going to rename it, it'll be easier this way, as 70 minus 1, and square it. All right, so 70 times 70 would be 4,900, minus 70 times 1 is 70, and if we double that, that'd be minus 140. And then we take our last term, negative 1, and square it, which would be plus 1. So putting these all together, 4,900 minus 140 would be 4,760, plus 1 would be 4,761 for our answer. And you can double check these with your calculator to show that this works. Okay, the product of a sum and a difference of the same two terms is the difference of their squares. All right, so we're going to apply this, and then I'll show you using FOIL why it works. All right, so notice we have A plus B, and then we have the same two terms, A minus B. All right, so what we get is we take the A and square it, and difference means subtract, and then we take the B and square it, and so we have A squared minus B squared. Let's do the same thing with the next one. Our first term is X, we square that. Our second term is 9, or I'm sorry, excuse me, it's 3, and we square that, which is 9, and then it's the difference of the two, so X squared minus 9. Now, why does this work? All right, well, if we FOILed this problem, X times X is X squared. Our outer terms, X times minus 3 would be minus 3X. Our inner terms, positive 3 times X would be a positive 3X. And then our last terms, positive 3 times negative 3 would be a minus 9. Well, look what happens in the middle. And this is going to happen every time that you've got the same two terms, but you've got a plus in one factor and a minus in the other. The minus 3x and the plus 3x is equal to 0. So it's going to cancel out. And then what you have left are your first term, x squared, and then your last term, which is minus the square of the second term, so x squared minus 9. This happens on the first one too. If you FOIL a plus b times a minus b, you get a squared minus ab plus ab minus b squared. And so the middle two terms, the outer term and the inner term, are equal to 0 when you put them together. So once again, you're just left with your first term and your last term, and it's the difference between those two squares. All right, problem 4, finding the product of a sum and a difference. So simpler form. Now again, you can FOIL these, but when you recognize that this is a difference, or this is a product of a sum and a difference, then apply the rule. X times x is x squared. You know that the outer term, minus 9x and plus 9x, are going to cancel out. And it's always going to be a minus. 9 times 9 is 81. And so x squared minus 81 would be your product. Using it on the next one, 6 times 6 is 36. You know the outer term and inner term will cancel out. And then m squared times m squared would be m to the 4th. And so we have 36 minus m to the 4th. And on the last one, and looks like my parentheses are totally messed up here. Let me just redraw those. Okay, so we have 3c times 3c would be 9c squared minus the outer term and inner term will combined equal 0. And so we have minus 4 times 4 is 16. And there is our answer. All right, so let's apply this to some number problems. Let's rename 52 as 50 plus 2 and 48 as 50 minus 2. All right, and then squaring our first term, 50 times 50 is 2,500. We know that the outer term and inner term will cancel out. In fact, we're going to have negative 100 plus 100, so that's equal to 0. And then our last term, 2 times 2 is 4. So 2,500 minus 4 would be 2,496. Our next problem, 17 times 23. Well, as you might guess, we're going to take 17 and rename it as 20 minus 3. And we're going to rename 23 as 20 plus 3. applying this principle to this problem, all we have to do is multiply our first terms together minus and multiply our last terms together. So 20 times 20 is 400. 3 times 3 is 9, and subtract the 2, and we get 391. All right, you might want to try these problems. Worksheet 8.4, it will be available in the classroom. And if you have questions, please don't hesitate to ask. Always know on this lesson that you can use FOIL, and if you forget how to do it, use FOIL or another multiplication method. But what you will always find on these is that your middle term will cancel out if you have one that's a plus and one that's a minus. If they're both pluses or both minus, then it's going to be twice either your outer term or your, let me say it this way, your outer term and your inner term are exactly the same. So it's 2 times the product of the two terms. Thank you, and if you have a question, please ask.